Hallo, it's Dumplet here. Here's an item on geometry. We have a rhombus, and we have two 60-degree arcs highlighted in blue with centers at two of its vertices, as you can see here. We have the bottom left vertex and the top right vertex to be the centers of the two arcs. If the red circle, the inscribed circle, has area pi, find the perimeter of the rhombus. This item came from DAM 2022, an examination that Dumplet has hosted. The link to the PDF file will be in the description. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Alright, because the two vertices in green are the centers of the two arcs, essentially we could get that the central angle would have to be 60 degrees because we do have two 60-degree arcs, so obviously the central angle would have to be the same measure as the arc, so two 60-degree angles here. Next, we do know that rhombus is just a quadrilateral with four equal sides, so essentially a rhombus is just like two isosceles triangles being connected by a common side. Let's just say this is the common side in dashed line. So, but we do have two isosceles triangles with a vertex angle of 60 degrees. So that's going to mean that these two angles over here, I'm going to highlight in red, they add up to 120 degrees. So 180 minus 60, so 120 degrees. So they each should have a measure of 120 over 2, so 60 degrees, right? And by similar reasoning, these two would have to be 60 degrees as well. Now, essentially, it's just two equilateral triangles glued together, I guess, at this side, the dashed side. So we can kind of view this problem as just, okay, we can view the rhombus as just two equilateral triangles just connected by a common side, right? Now, what this is gonna do is to help us create a nice representation for some of the sides here, right? Now, let's just say the side of the rhombus is S, okay? Now, we can kind of recall some of the properties of the parallelogram and the rhombus. So, in a parallelogram, diagonals bisect each other. So, if I drew out the two diagonals here, this would have to be the same as this one, right? Now, obviously, this would have to be the same as this one as well, okay? So, that's that. But what's more important is this side, because we know this part is just a side of the two equilateral triangles that we have. So we know that this entire segment would have to be of length S as well. So half of this portion would have to be S over 2. Now I drew out a smaller version here just to make it clear and to get rid of all the unnecessary lines. So we have S here, right? And then we have this part to be S over 2. Now, some properties of a rhombus: diagonals are perpendicular to each other, actually. So there should be a right angle here at the center of the circle. Again, because of nice symmetry, the two diagonals should intersect at the center of the circle. So there should be a right angle here. Now, let's try to find a representation for the last side, so this side. Now, we could view this as this entire thing minus the radius of the circle, right? It's going to be this entire thing minus the radius of the circle. So let's talk about the entire thing here. Now, the entire thing is essentially just from the center to a point on the arc. Essentially, this is the radius of the circle. Now, that's the same thing as saying S then. It's the same thing as saying S over here. So this entire thing would have to be S. Now, what's the radius of the small circle? Let's just go back to the question. We have the area of the circle, so pi r squared. The area was equal to pi. So, well, r squared here will have to be 1. The radius of the circle is 1. So this red portion over here is 1. So this segment would have to be the entire thing S minus the radius of 1. So this portion will be S minus 1. Okay? Now we do have a right triangle, and we do have the three sides in terms of S, so we should be able to write down the Pythagorean theorem. So S over 2 squared, so this should be S squared over 4, plus S minus 1 squared, so S squared minus 2S plus 1, that should be equal to s squared, right? Essentially, we just have to solve for this one. Okay, so I'm going to put it here. We have s squared over 4 plus s squared minus 2s plus 1. That was equal to s squared. I could cancel the s squared. So I'll just have s squared over 4. I'll multiply both sides by 4. So s squared minus 8s plus 4 is equal to 0, right? By the quadratic formula, because unfortunately this is not factorable, s would be 8 plus minus square root of b squared, 64, minus 4ac, so 4 times 1 times 4, that's going to be 16. So 64 minus 16 is 48. 48 is 16 times 3, so I could bring the 16 out. So square root of 48 is essentially 4 times the square root of 3, then divide this by 2. So s here would be I have 4 plus minus 2 square root 3. Now let's think about this, because there are two values for s. 4 plus 2 square root 3 versus 4 minus 2 square root 3. Now, square root of 3 is approximately 1.7. So 4 minus 2 square root 3 is going to be approximately 0.6. Approximately 0.6. Now, we know that the radius of the circle is going to be 1. So, well, I don't think s could be less than the radius of the circle, because it doesn't really make sense. So, well, that's an easy way for us to cancel this one. So we should have s to be 4 plus 2 square root 3. So the side of the rhombus is 4 plus 2 square root of 3. So if you want to get the perimeter, just multiply it by 4. Since the 4 sides of the rhombus are all equal, we're going to get 16 plus 8 square root 3. So from 4 plus 2 square root of 3, just multiply this by 4. 4 times 4 gives the 16. 2 square root of 3 times 4 gives the 8 square root 3. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye-bye!